Good morning again and welcome to this webinar. Thank you very much for joining us today. My name is Luis Bellido from the training department at SODECA and I'll be your host for this webinar. Today's session is part of our micro-learning series, a focused 30-minute format designed to explore key technical topics in a clear and practical way. At the end of the presentation, I will share the slides with you and we will also have a moment to answer your questions. So you can send them to us at any time using the question box in your control panel. In this webinar, we will explore the design of ventilation system in Passivhaus certification. As many of you know, ventilation plays a central role in achieving Passivhaus standards. Today, I'm very pleased to have Carlos Martinez with us as a speaker. Carlos is responsible for the training department at SODECA and brings extensive experience in design of high efficiency ventilation systems with a strong focus on Passivhaus principles. So, without further ado, let's get straight into it. Carlos, the floor is yours.
Thank you, Luis, for your nice presentation. Let's start with this first session of our micro-learning program in this 2026. I am glad to be here for another year, sharing the experience of SODECA in ventilation systems. And I think the topic today is very useful for us at this moment because I am going to talk about one of the most important certifications today around the building standards. And let's start with the presentation, okay? So I think everybody can see my screen, everybody can hear me properly, so I'm going to start. So the title of the training today is Design of Ventilation System in Passivhaus Certification. Let's start with a brief introduction. Speaking about the current reality of both new construction and building refurbishment is that we are increasingly constructing buildings with much better thermal insulation and a very high air tightness levels. These strategies are excellent for reducing energy demand and consumption in buildings, as they eliminate I could say, natural microventilation that used to occur in poorly insulated structure. Okay, it's not a ventilation we want, but it is occurs because of the defects in the construction. Okay, however, if these measures, as we will see in a couple of slides, are implemented without an holistic approach, they can generate secondary health-related issues. So we need to bear in mind that every architectural or refurbished approach we have in mind, we bear in mind, need to be considered from different parts of the project, not only insulation, but also taking into account ventilation systems. Why? Because it's becoming quite common for buildings that undergo these improvements to experience condensation-related moisture. Okay, as you can see in the image, these problems are typically appears near to the windows. Okay, near to the points that are more cold than the surroundings. Okay, so this occurs basically because mechanical ventilation has not been reinforce it or bearing in mind accordingly. Okay, when unintentional natural ventilation is eliminated, okay, we increase the energy efficiency of the building, but also pollutants begin to accumulate indoors. We need to bear in mind that we are exposed to several pollutants that generate inside the buildings just because of the human activity. Humidity is one of these few pollutants we need to fight, and it's the one that become visible to the naked eye, but it's not the only one. There are other harmful pollutants that can also build up and can be potentially a problem for us, for our health. Okay. Architectural trends have changed significantly over the years. For example, in the 19th century, buildings were constructed primarily to protect us from the outdoor environment and with the main objective of being warm and safety inside our houses, inside our buildings, okay? Then during the 20th century, with the technological development, buildings became filled with all kinds of systems, all kinds of installations that improve the comfort, okay? Improved really, really high levels of comfort, really, really high levels of good being, but also led unprecedented energy consumption. We increased the energy consumption inside the buildings in this time for much more than in the 19th century. So the trend in this 21st century, sorry, is to construct buildings that behave almost like coffee thermos flask. Okay, we want to keep the energy inside the buildings, and if we build like that, we will require very little energy to achieve comfort. But the key factor here, as you can see in the image, is that these strategies need to be supported by mechanical ventilation system with heat recovery. And that's why we are here today trying to explain the importance of the mechanical ventilation in the Passivhaus certification, okay? And what is the Passivhaus certification? Okay, the paradigm of all these new architectural trends is the Passivhaus certification. Although it's not a mandatory standard, but I think it's setting the foundation and probably becoming like a benchmark for building regulation worldwide. Why? Because it is based on the combination of 5 fundamental principles. First of all, very high levels of thermal insulation, okay? Then, as I told you, an excellent air tightness. Then also important, the thermal breach-free design, okay? We are paying attention to this point of the house or of the building when we can find this thermal breach, and we are eliminating it, especially focus on the windows, for example. And speaking about the window, this is the fourth principle, the performance of the joinery, okay? Especially the windows need to be exceptional. And the fifth principle, last but not least, is the use of mechanical ventilation systems with heat recovery. So regarding all these 5 principles, as you can notice, we are focusing today in this last one, the use of mechanical ventilation and the design of mechanical ventilation inside or in the focusing in the Passivhaus certification, okay? So before I start with the design of the system, let's speak about the most important part of the system, that is the heat recovery unit. What is a heat recovery unit? Okay, a heat recovery unit is equipment that, first of all, has 2 different fans. One fan we are using to introduce fresh air from outside to inside, and another fan integrated in the same equipment that is used to extract the dirty air or the not as well air inside the building and extracting outside the building. Okay, so we are working here with the principle of the dilution. Okay, we are introducing fresh air and we are removing dirty air. Okay, so a heat recovery unit is an equipment that uses the energy from the air extracted to heat or cool the incoming fresh air. So, okay, the 2 airflows are not mixed inside the equipment. Each flow it's going to be in its duct, but there is an exchanger that is like the core of the equipment where this exchange of energy is occurring. Okay, so using heat recovery unit allows us to introduce fresh air without losing energy or not losing as much energy as, for example, natural ventilation. Okay, here you have an example. Imagine the situation: we have a winter condition of 0 degrees outside the building, and we have connected the heating system in order to achieve more or less 20 degrees inside the buildings, inside the houses. So when we use the heat recovery unit, this energy is exchanging, and we are introducing the air not at 0 degrees, but at 16, 17 degrees. So the leap between the objective temperature and the temperature we are in of the air we are introducing inside is not as big as could be. So the use of heat recovery units in general in all kind of projects, not only in passive house projects, it's going to mean energy savings, economic savings that are really related, thermal comfort, and also indoor air quality. We are using very specialized equipment with mechanical filters in both supply air and extracting air, and we are improving also the indoor air quality because we are diluting the pollutants and we are introducing fresh air from outside. Okay, so just a couple of main characteristics of the heat recovery units that we need to bear in mind in order to select or to choose the better option for us. Okay, first of all, we need to think that there exist basically two different types of exchanger. Okay, we have sensible exchangers and enthalpy exchangers. Sensible exchangers recover the energy from the temperature differences between two airflows. On the other hand, enthalpy recover the energy from both temperature and humidity differences between two airflows. That does mean that enthalpy exchangers are better. Not always. We need to bear in mind that it is necessary big differences between the humidity inside and outside the building in order to improve the energy exchanging. Okay, so probably enthalpy exchangers are more suitable for projects in places with high humidity rates, for example, in the coasts, or in these places that the difference between outside and inside humidity are big. For example, I can imagine a gym or a place, a bar, or some place that the humidity will increase because of the presence of the people, but outside is not too high humidity. Okay, so speaking clearly, enthalpy we will use in coast cities or places with high humidity levels, and sensible we will use in the rest of the projects. Okay, so another important characteristic of the heat recovery unit, not all the heat recovery units in the market have it or have it automatically, is the bypass. Okay, the bypass is a device that diverts the airflow and prevents it from passing through the heat recovery unit. So we are preventing for the thermal exchange occur. Why? Because could be situations that could be necessary to supply direct air from outside. For example, if we need a free cooling. What is a free cooling? A free cooling is a rapid cooling of the indoor air using the bypass mode. So if the temperature sensor detects that the temperature outside, for example, in summertime, is lower than inside, it could be interesting for us, instead of using air conditioning system, to use the bypass mode and to have a free cooling of the indoor air. Okay, so that's why the bypass is so important, and it's going to be a key factor in the energy efficiency of this equipment. On the other hand, it is also important in plate heat exchanger like the ones we are presenting today, that we could have a frost protection. Okay, reduce the risk of freezing during the winter. If we have low temperatures outside and we don't have an electrical preheater that is very common to have in some climates, the bypass will allowing us to protect the exchanger. Okay. So let's explain more in detail the details of or the requirements of passive house certification regarding the ventilation system. Okay. First of all, we can calculate the airflow we need in our projects using these two different methods. We can calculate per person or per air changes hour. Per person, we need to bear in mind 30 cubic meter per hour for each person we will have inside the house. And using the total volume of the house, we can also calculate 0.3 air changes per hour in order to calculate the airflow. We normally will use the result of these two methods, that is a higher requirement. Okay. Another important thing about ventilation system is that in passive house certification, it is mandatory to make a flow control and a balancing of the flows after the installation of the equipment. So we need to have mandatory at least 4 speeds. Okay, 1 speed for standby, that the equipment it needs to consume less than 1 watt. 1 reduced speed for the 70% of the nominal flow, the normal speed for 100% of the nominal flow, and the intense speed for the 130% of the nominal flow. So at the end of the day, we are calculating the airflow, but we need to bear in mind this 30% more to achieve the intense speed. Okay. So for example, if we have 100 cubic meter per hour that we calculate using one of the two methods I told you, we need to select a heat recovery unit able to give us 130 cubic meter per hour to achieve this intense speed. Okay. We also have requirements in performance and consumption. It is mandatory that the heat recovery units have a minimum performance of 75% of recovering, heating recovering, okay? And the specific consumption of the equipment is need to be less than 0.45 watts per hour than cubic meter, okay? Regarding the air velocity in the duct, that is really related with the next point, that is acoustic requirement. It is mandatory that in the main ducts, we don't have more velocity than 4 meters per second, and in the secondary ducts, less than, the secondary ducts are the one in contact with the main rooms. For example, in this picture you have here, this will be the secondary ducts and this will be the main ducts. The requirement is less than 2 meters per second, okay? Regarding the acoustic requirements, okay, the noise is one of the most important factors in order to bear in mind in the ventilation design system. Normally, most of the complaints about the installation is about the noise, so Passive House take care of the noise also with these acoustic requirements. The noise pressure need to be less than 25 decibels in living room, less than 30 decibels in bathroom and kitchens, and less than 35 decibels in the installation room, okay, the room where we are installing the equipment. And for mechanical filters, it's mandatory to have a mechanical filter in the supply MERV 13 or F7, and in the south MERV 7, 8 or G4, okay? We have a main filter F7 and a gross filter G4 for the exhaust. That's the minimum, okay? You always can improve the efficiency of the filtration, okay? So in SODECA, we have 2 equipment certificated for passive house compliance. It is not mandatory to have this certification, okay? It is mandatory to have a heat recovery unit in the project, but it is not mandatory that the heat recovery unit is certified by Passive House. But the performance declared by us, by the manufacturer, is reduced by 12% if the unit is not Passivhaus certified. Okay, so that's why we have the certification of these two equipment that basically in our range of products are the smaller and the bigger. And we have this certification for both cold climate and digamos not so hot climate but medium climate. Okay, as you can see in the picture you have. So what are the important tests that our equipment pass in order to achieve this certification? For example, as I told you, we have a heat recovery rate more than 75, 78 in our case, and a specific electric power consumption less than 0.45, in our case 0.36. And for example, another useful test is that we need to have a percentage of leakage less than 5%, in our case 3%. This is a data that can help us to understand that the insulation of the equipment is very good, because we are not having leakage of both air and energy in our equipment. And also there is another test that certified that the equipment can work with an outdoor air temperature less than minus 10 degrees, and supply air at temperature of 16.5 degrees. Okay, this is using the preheater, the electric preheater. But as you can see, the equipment, even being a plate exchanger, could work at very, very low temperatures. Okay, so this is the picture of our range of products. I am going to speak today basically about the AirHome 150, because it's the most suitable of the equipment for almost 90% of the project, because the airflows we are working with are not as big as, for example, in non-residential buildings. So as a model example, I am going to talk about the AirHome 150. One of the first characteristics I want to remark is the low noise level we have of time with our equipment. It is very quiet, and we only have 26 decibels with the measure make it in the installation room. Okay, the measure is in the installation room at 1.5 meter of distance of the equipment. Basically, if we are stand up, for example, in the bathroom, and in the falls in the bathroom is the equipment. So the noise level is 26 decibels. If you remember, the requirement for Passivhaus is 35 decibels. So we are quite below the level. Okay. Another important characteristic, I think, is the low profile, because we have a very compact design. It is only 210 millimeters high, so it is perfect for the installation in the false ceiling. That's one of the best characteristics of the heat exchanger using plates, that in general we can make equipment more flat, and we can save space in order to have another installations in the house. So the low profile is another very good characteristic. Here you have another important characteristic. I know I don't have so much time to go step by step in there, but I am going to remark two very important for me. The first one is that we have removable F7 filters in both in the supply air duct and in the extract air, and that's very useful for us in order to obtain easily the balancing of the flow. That is a very important requirement, and we are protecting both of our health in the supply air and the exchanger in the extract air, so we can extend the life of the equipment. Okay. And another important characteristic is the use of this control that is already included in the price. Okay, you don't need to ask for the control. The control is included, and it's a very, very useful control in order to monitorize the state of the temperatures. For example, the user can see the different temperature outside and inside the houses, so can see that the equipment is working. and also can have a variable velocity, a variable speed based on demand ventilation. Okay, we have indoor air quality sensors that are installed not in the control but in the extraction nozzle. That's because in the extraction nozzle we can have an average of what are the pollutant levels in all the house, not only in the part of the house that the installer has installed the control. So for us, it's very important that this indoor quality is reliable. So we can control and modify the velocity of the fans and the total flow we are delivering by following the concentration of carbon dioxide that is very related with the presence of person, and also the concentration of volatile organic compounds. That's an amazing characteristic that we are using. Okay. This is a normal installation of the equipment. We have two different set of ducts. The blue ones are for the supply air, and the red ones are for the extraction air. As I told you, normally this is the installation type because we need to do a complete air changing in the house. So that's the characteristic that will allow us to have a complete air changing in all the house. Okay, we are supplying fresh air in the dry rooms, and we are extracting the air from the kitchens and the bathrooms in the bedrooms. Okay, so that are the accessories we will use in our case. I am going to change to the other slide because it is very important the influence of the duct type or the distribution type we are selecting. Basically, we have two different distribution systems, the tree system and the star system. Okay, this one is based on one main duct and other secondary ducts. And in this occasion, this is based on the use of distribution box. Okay, each room has its specific duct. So why we are using, or why we are delivering the star system? Because it gives us greater flexibility and easy of installation. It will not depend on the drawings. So for example, if there is a discordance between the drawings and the reality, the installer could easily adapt using the star system, but not so easily using the tree system. Okay. Another great reason is we will have a greater ease of the flow control. I will show you briefly this sixth accessory that is the flow regulator. So we can regulate the flow in each inlet or outlet. So it is very easy for the installer in the moment that we need to do this balance and this flow control to do it in the star system. In the tree system is more complicated because we need to bear in mind the number of elbows, the size of the ducts, so could be tricky. Also with the star system, we will have a lower transmission of the noise. You can imagine, for example, using the tree system that the living room and the rooms are connected. So the noise for the living room is going to transmit to the rooms. And using the star system, we isolate every room. So it is not as possible the transmission of the noise. Okay. And finally, another reason is that the installation time is really low in comparison with the tree system. It's very easy to install. Okay. So just to finish with the presentation, this is a main example about the calculation of the flows you can have using both, for example, Passivhaus and another standard that it is mandatory in some parts of the world, that is ASRAE 62.2. Okay, using the Passivhaus standard, as you can see, with the first method we have 150 cubic meter per hours of total flow, and using the air changing method, we will have 90 cubic meter per hour. So we will use the more restrictive, and in comparison with ASRAE, you could see that we are increasing a little bit the ventilation rate, and we are increasing, of course, the indoor quality because we are be able to dilute more the pollutants. Okay. So that's the final slide. This is an example of calculation at how much energy savings we can have using heat recovery units alone. Okay, we are not taking into account the use of, for example, insulation or high tightness. We only are introducing a heat recovery unit in a single family dwelling that has not in the past. Okay, so this is an example of a single family dwelling in Madrid with a heating system of a classical oil boiler, a cooling system using, for example, air conditioning, and this is more or less the annual air conditioning cost. Okay, so if we install the heat recovery units and we used a formula that is based on some documents that are approved for the Energy Efficiency Ministry of Spain, we can easily calculate the total savings for the year that are around 3.5 kilowatt hour per year. And if we translate this to economic savings, we are talking about more or less 30% less in comparison with the hypothesis of not using heat recovery unit. So at the end of the day, you need to bear in mind that using heat recovery units, even in passive house certification, is mandatory, but even if we are not using or we are not projected using passive house, we need to bear in mind that the return of the inversion of this equipment, far away from being a cost, is an opportunity, because we are obtaining the returning in more or less from 3 to 5 years. This is in function of the type of climate we have and the energy consumption we have already. So just to ramp up all these things, in passive house certification, heat recovery units are a key factor to obtain the certification. It is very important to improve the indoor air quality and also to reduce the energy consumption. So I know that probably micro-learning style is a little bit, we are in a rush, but I think for 30 minutes it is a very good summarize of the main important points in the passive house certification regarding the ventilation system. Thank you so much for your attention, and I think now is the time for the questions and for share with you the presentation.
Thank you very much, Carlos, for that fantastic presentation. I'm sure everyone found it really insightful. While Carlos takes a quick sip of water, I'm going to share the presentation with you. You'll see it appear in your control panel shortly. So here we go. Okay. It's uploading. Okay, yeah, we are. Now we will move into our question and answer segment. I'll be reading to Carlos the questions so he can provide his insights and guidance. So let me check if we have any question. Okay, so Carlos, the presentation was crystal clear. Okay, here we have the first question. So let's get started with the first question. So, Carlos, when you calculate the air speed of 4 meters per second for main duct and 2 meters per second for branches, do you calculate with 130% intense velocity?
Yeah, that's a very good question. Of course, we need to take the velocity for the intense mode. So yes, we need to calculate, bear in mind this 130% more of the intense mode. So it is a very good question, and yes, you need to calculate using the intense mode.
Okay, thank you, Carlos. Thank you for Jen Kuku. Okay, we have a second question. The energy savings consider a system of air conditioning plus heat recovery?
Sorry, can repeat, please, Luis? I lost part of the question.
The energy saving consider a system of air conditioning plus heat recovery?
The energy, yeah. Here we are considering a normal single family dwelling in the north of Madrid. Okay, that at the start we have both heating system using an oil boiler and air conditioning system based on splits, okay, split units. Then when we introduce the heat recovery unit, we need to bear in mind the consumption of these heating and cooling systems, and also the consumption of the heat recovery unit. Even taking into account the consumption of the heat recovery units, we are recovering more energy than we are spending using it. So yes, we are taking into account the annual air conditioning cost, and we are reducing the air conditioning cost even using the heat recovery unit by 30%.
Okay. Tatiana, congratulate you for the presentation. That's what our final question for today. Thank you very much, Carlos. In any case, to the audience, if you have any further question, you can find Carlos' email on this last slide of the presentation. Feel free to reach out to him directly. He will back to you as soon as possible. And finally, I would like to thank you all again for participating in this webinar. I really look forward to seeing you at our next session. So be sure to stay tuned to our LinkedIn page for upcoming webinars. And that's all. Thank you very much again for your participation, and see you soon. Bye.
Thank you, Luis, for your nice hosting. As Luis me told you, here you have my personal email. You can reach me. You have further questions, and see you in the next micro learnings. Thank you.